Hey everyone, can you hear me? Yes, cool. Hi everyone, thank you all for coming. My name is Nebojša, I'll be moderating this panel. I wasn't supposed to moderate, I was supposed to be sitting with these guys, but nevertheless, the moderator is missing, so I'll fill in. So what we can do for the beginning is we can do a round of introduction, so you can state your name and what do you do?
Yeah, hi everyone. My name is Kirill. I'm an engineer at BlockScout, which is an open source, the largest open source EVM explorer in the number of chains. We support, so yeah, I'm an engineer there and the head of protocol research. So we do a lot of stuff in researching and supporting different EIPs, rollups, and different customizations for each of those chains. So yeah.
Oh, hello everyone, welcome to the panel. My name is Mamageishvili. I am research scientist at Off-Chain Labs, which is a company that built Arbitrum chain that you may know better.
Great. Hi, everyone. My name is Gorzny. I am a technical lead and co-founder at Circuit, which is a zero knowledge rollup, and I'm excited to be here to talk with everyone on the panel. So I guess I'll pass.
And my name is Nebojša. As mentioned, I'm one of the co-founders at Tenderly, mainly working on some of the core technology behind Tenderly, and currently I'm leading the R&D department. So to kick things off, let's try and address what are some of the core differences in the implementation between layer 1 and layer 2 technology. Whoever wants to go first.
Okay, yeah, sure, I can start. I don't know about core differences. I mean, the L2s and L1s obviously will do a lot of different features across the board. So like Starknet and Ethereum, for example, massively different core differences, right? Different VM, incredibly different architecture and design. But I think, you know, if this is a panel on EVM equivalence, I'll sort of disregard Starknet for most of this conversation and say there's definitely some other things that I find really annoying that aren't well advertised. And so some of these are like implementing the sort of EVM opcodes in the way that you would sort of expect from a standpoint of an application developer. So including them, but not necessarily mimicking the semantics of them. So if you look at the block time number or the block time or the block number on an L2, it's not the same on every L2. And so if you start to fork, you know, your standard Solidity contracts and DeFi that compute interest or yields based off of either of those parameters, they're actually not going to necessarily perform the same out of the box on all of your so-called EVM equivalent or EVM compatible chains. So I think that's a pretty big issue. I don't know that it's core because, you know, in principle, those DeFi protocols can just change it to their chain. But we were sold on this notion that EVM compatibility or equivalence means I don't have to do any additional work. I can just take my contracts and it'll work exactly the same. Mm-hmm. And I like these examples because they're actually really subtle. Like no one really talks about them. And there's actually, you know, there's good people doing good things to advertise some of them. I'm hogging the mic here, so I'll wrap up in a second. Like L2Beat does a lot of things like discusses the security implications of rollups and things like this. But only recently have we seen websites and other people talk about, oh, these small subtle changes. Mm-hmm. So there's a site called Rollup Codes now that changes or discusses the changes of these opcodes. And I think that's pretty important, if not core. And then there's probably other things I can talk about, but I'll pass it.
Yeah, so I was actually searching what is the definition of EVM, and I didn't find the exact formal definition of that. But my understanding is most of it, when people talk about EVM compatibility, refers to execution. And there I think at least Arbitrum tries very hard to be exactly compatible with Ethereum on the execution layer. So it has implemented Geth for the state transition function. But there is another big part, which is consensus, and this is, I think, what Jan was referring, how transactions are grouped together. And in case of Arbitrum, this like quarter-second block times, which is 4 times 12, 48 times shorter than Ethereum block time. And of course, our application writers should know about this, and they need to adjust their interest rate or whatever this is. But I think, yeah, if this is not talked to the public, this at least should be taken very seriously by applications, that execution layer stays the same, yes, but consensus layer is very, very different. And I'm absolutely fine that it's different because that's where rollups gain. So this is their selling point, that they have much faster block times. They have centralized sequencer, which maybe doesn't sound good for decentralized system, but it handles transactions much faster. And if rollups had the same consensus layer as Ethereum does, they would be same slow and same inefficient. And I think rollups need to like give some improved experience to users. And yeah, so second difference is pricing, and this also should be taken into account, especially by applications that have some long-term contracts deployed, and they count on. So it's not users who interact with the chain, but it's some contract that pays in the name of users. So pricing can also not be the same, because, for example, in case of Arbitrum that has quarter-second blocks, and there can be a lot of transactions in the same block, it needs to adjust the fee. It cannot wait like Ethereum waits 12 seconds and adjusts by 12.5% maximum. So it can happen that on Arbitrum, the fee spikes much faster than on Ethereum. And that is just inevitable by just having such a short block times. And this should, again, be taken into account. I would not call this is a security issue, but more like economic, which can become security issue if those who design smart contract counted on 12 seconds and the price update like it is happening on the Ethereum. So it can become security issue, but in principle, it's not security issue.
Yeah, I'll probably add that so with all of these different types of rollups we have today, it's probably already so many different implementations that we can almost for sure say that we won't be able to come back to the same kind of ideal EVM implementation that's the same across the board and doesn't have any differences across different L1 and L2s. So we'll have to live on and go forward with this difference in mind. So this basically we see differences across the stack. There are some low-level differences on like the protocol level. So some L1s and L2s support certain transaction types that others are don't. There are like differences between the block times, as was already mentioned, in the way how gas prices and gas limits work, how the fees are subtracted from the accounts. Then there are like different implications from the transaction inclusion perspective, like certain MEV kind of stuff can only happen in certain chains and cannot happen in others. So there are like different kinds of manipulations that can be done in some places and cannot be done in other rollups. So that's something that should be accounted for. There are a lot of other like security implications, again, with some specific opcodes, with some specific precompiles, which can also be present in one rollups and missing in the other. And another issue is that the space is constantly changing. So we have like hard forks which are happening with its own timeline on Ethereum mainnet, but then all the layer 2s, they have like their own schedule, their own changes. Some of these changes, they kind of rely on the schedule of the Ethereum mainnet, some are not, so they all happen different times. It also kind of affects how the space is moving forward and how we kind of need to support all of these different implementations and nuances at the same time.
Cool. Nice answers, guys. So we mentioned some of the differences occurring on layer 1 and layer 2, and we touched base on the EVM compatibility and equivalence. So maybe we can dig deeper down there. So what are some of the distinguishes between those two? What are some of the implications of that, and how do developers adapt to that?
Yeah, so I think the first thing we need to do is kind of try to define what's the EVM compatibility and what's the EVM equivalence. The way I understand it is that compatibility is something that just anything that looks like an EVM is something that's EVM compatible. So if you're running something compiled from Solidity or something similar, then your platform is probably EVM compatible. But then equivalence is something a bit more narrow. So it's probably already includes that you need to support certain opcodes, certain precompiles, and they will need to work in the same way they work like for the Ethereum mainnet. They should have the same gas pricing and so on. So yeah, of course, the level of this equivalence, it impacts the different security considerations. So the more you are equivalent and the closer you are to the Ethereum mainnet, it's probably the simpler it is to kind of deploy some protocol and copy it from the Ethereum mainnet and deploy it without any changes to the layer 2s, without thinking of some increased security concerns or whatever. But in the end of the game, yeah, probably no chain and no rollup will be fully 100% EVM equivalent with the Ethereum mainnet. So basically, anytime the developer is launching their protocol in this multi-chain space, they need to spend some time to review what changes and what differences are between like their rollup of choice and the Ethereum mainnet or whatever their protocol was deployed before, and kind of try to understand what are the security assumptions and how they will be different when this deployment will go live. Yeah.
Thank you. Yeah, actually, I was looking into the distinction between these two concepts, and what is my understanding. I agree completely with Kirill that there is no clear difference. Like this is the definition of compatible, and this is definition of equivalence, and these two definitions are different. From my understanding, people use these terms, especially equivalence, for maybe marketing reasons. Let's say many chains, rollups say they are compatible, and they are compatible, while some say we are more compatible, but nobody wants to say more compatible, so they say we are equivalent. But as Kirill also said, there is no 100% equivalent in the sense of mathematical definition, because there is different block times, there is different pricing, so nobody is 100% equivalent, but it can be that some chain claims they are compatible, another chain claims they are equivalent, and in reality, compatible one is closer to Ethereum EVM than the one that claims that they are equivalent. So that's my understanding, but maybe Jan has different.
I mean, and I'm not trying to contradict. I think that's a good point that like a lot of it is marketing. But to sort of go back to the initial question and something that you guys haven't touched on yet, this notion of equivalence is sometimes used to like, oh, you know, the execution layer is the same, but behind the scenes we're going to change how we record state, or you know, we'll use a different, more zero-knowledge friendly hash function to compute a state root rather than Kesak, because Kesak sucks in a zero-knowledge proof. And I think, you know, that distinguishing thing is really nice when you are engineering that part, but otherwise, like the app users don't really care. I think for them, EVM compatible sort of should be good enough, right? This definition change between compatible and equivalence is technically important, but it is not well defined, so it's important, but also no one's done it, so how important is it? Or maybe people have done it, we just haven't seen it. But I think compatibility is key, and to touch on the original question of you know, some of the specific differences, changing these backends, so how state is recorded, that is important, and it's one of the reasons we sort of had, I think, slow adoption in the zero-knowledge space is because Kesak sucked so hard. And you had to re-engineer these parts of Geth, for example, to make it work. On an optimistic rollup, they could bypass all of that. Kesak didn't matter. Like you could keep using it, and it was really nice. So I think the compatibility is very, very key, and as long as that is used in the right marketing sense, so like no one's lying about that you can generally port Solidity and it, you know, works very well, or whatever other language you're using to compile on your EVM, that's good. But the last thing I want to touch on is, I think it's also kind of important to say, you know, to which EVM you're compatible, because I would bet there are rollups out there that still don't support Shanghai or different opcodes, and so what ends up happening is you don't support the newest opcode because Ethereum just pushed it out and they had a good lots of tests, and then people fill up your Discord with like, hey, my code's not compiling, I thought you were EVM compatible. You're like, well, yeah, just the older version for now, and we're working on the next one. And actually, I think one of the big challenges is going to be keeping all of the chains who claim to be compatible up to date with Ethereum and one another, especially when there are changes that happen on this sort of equivalence end, so the back end. Shanghai might not be super hard to support, but if it means also changing your zero-knowledge proof system because you've done something along the way to make that more convenient for you, it's going to be very difficult. And actually what I think we'll see for other reasons too is just people deviating from EVM compatibility. In the next couple of years, you'll have that as the marketing thing. And you can sort of, I think, see it. Obviously, Starknet I already touched on, but like, I think Tyco is introducing new opcodes. So if they have new opcodes, I can't imagine they can use the phrase equivalent because that opcode doesn't exist in one of the EVMs. But that doesn't mean it's a bad thing. And I think it's actually really cool that people are trying these new things. As long as it remains mostly compatible for now, because that's where the developers are in the space, right? We still want most of Solidity to work.
Cool. And from a developer perspective, like, and you mentioned like some chains, like for example, not supporting some of the latest hard forks. Like, what are the things that I need to worry about when trying to migrate some of the contract that I already have on layer 1 to layer 2? Like, for example, what if some opcodes are not supported on layer 2 still?
Yeah, I don't know. The easy way is to try it. Ideally, they have a testnet, so you can just try it and it doesn't work. And then you have good tests to check that yields are being computed correctly. Because sometimes, like I said, they will support the code. They'll just change the semantics. Otherwise, ideally, they have good documentation to say, look, we're only at Paris, not Shanghai. So don't try Solidity 820 or whatever the version is that that introduced push 0 or whatever that opcode was. Yeah, I don't know. Maybe some of the other ones have good answers. Good answer.
Okay, nothing else that developers need to worry about when migrating?
I mean, okay, so like I think that's a surface level one. I would imagine there's like ripple effects that will eventually start to happen, like gas computations of transactions might change. We also see some chains, support pre-AIP 155 transactions, some don't. There's some things on the tooling side that they will need to change if they always want to redeploy at a specific contract because they don't support that, or because they want to use that type of transaction, which is no longer supported by the VM. I think you need to sort of review everything, but testing will get you 90% of the way. And then talking to the team that you want to deploy on is probably going to get you the last 10%. You just you have a talk and say, hey, I'm doing this. Do you expect anything will break? And the answer should be no.
Okay. Yeah, sure. Go ahead.
Hold on 1 second. Let's get you a mic. So I have a very curious example which I encountered a few years ago when I was working with Polygon. Now Polygon chains actually basically validate a lot faster than Ethereum chains, but reorgs on Polygon can happen multiple blocks, like even like double-digit blocks ahead. I think maybe at some points even like 3-digit blocks pass. And so what you have is that there's the risk that when you do actually use on a chain which is faster, you still have to wait the same amount of time to actually get the kind of same finality as you would say. And so I realized that when I was building on the chain, and this is not an attack on Polygon, this is just an example that occurred to me, which is that you still end up waiting the same amount of time. Yes, the fees are cheaper, so that's great, but even if you look at exchanges today, when you're depositing some of the faster chains, the waiting time is still the same. So it's not really about the equivalence on EVM, but it's like something lower that then becomes a problem. Are there other pitfalls like that we do have to bear in mind? And it's nothing to do with Solidity, nothing to do with specifically the EVM, but it's stuff like this that we don't know as people who are working on a DApp, for example.
So yeah, I think we were going to talk about this as a question later, but that's one of the sort of later effects that isn't just like, oh, my Solidity didn't compile on my chain, but you have all these tools and infrastructure that aren't in Solidity trying to monitor that chain, which is supposed to be the same as any other chain. But if it's chugging along at 100 more blocks per second than the other one, their analytics engines won't perform the same computations, or they'll expect finality after 2 blocks or something that's EVM standard, but not on your chain. So I think that's a big problem. I would imagine people like explorers, indexes, and anything that's off-chain also need to change their tooling. Admittedly, I'm not an expert, so I'll pass it to someone.
Yeah, so I would not say this is a EVM compatibility problem. It's more like centralized exchanges and many other validators that look at the chain, even if the chain, let's say, has very fast block times, they really wait for Ethereum finality, so they don't necessarily trust sequencer fast feed, which is like less than 1 second, and there is block production also few seconds, but then they wait for Ethereum finality, which is at least 6 minutes. But that's application dependent, and I don't think this is a concern from the EVM compatibility side. But I agree that this should be communicated better, that what does EVM compatibility actually mean?
Yeah, like as Block Scout, as basically a part of the infrastructure that monitors all of this chain, I can add that this indeed is a big problem, that you have so many clients running across these different chains, and basically each implementation has some different aspects on the JSON RPC level, and then some assumptions about finality, these reorganizations. So definitely reorgs don't usually happen on layer 2s, but then if you have something like Polygon or Ethereum mainnet, then you can expect these different levels of reorgs with different depth. And that's something that for sure impacts any sort of indexers that work off chain and try to get something from the transactions, from the events. They need to handle this kind of reworks differently depending on their depth. Then, yeah, it also impacts in some way different front ends, I think, because a lot of front ends, they have like this general logic of tracking what happens to your transaction after you send it, and then there is different stuff like that can happen if you resend it, if it's get reorged, so some stuff may break during that. And yeah, as a part of the bigger problem, yeah, if you just take this JSON RPC compatibility, not just the EVM one, there is also a lot of differences on this level, so each client have some differences within this certain JSON RPC methods. So the Ethereum Foundation pushed a lot for the standardized tests during the preparation for the merge, but that basically only covered the set of like core EVM JSON RPC methods, but yeah, doesn't cover all of them. And then there are a lot of, it certainly doesn't cover these differences in the rollup JSON RPC implementation and node implementation. So yeah, there may be some problems there, as certain fields behave differently, certain formats may get changed, and there is no like standardized test suite that you can just run and make sure that your JSON RPC is also 100% compatible with the rest of the ecosystem.
Does that answer your question?
Yeah, it does address it partially in the sense that there's so many pitfalls that even though they are equivalent, it does address it. I guess my main question was, what are the pitfalls that we have to bear in mind too as developers, because it was something that I wasn't aware of until it affected our own the app. And so when people talk about equivalence, it probably just doesn't just sit on the EVM. So I was just curious what L2 issues might be too with that. Yeah, thank you.
Can I just say one? So I think the main takeaway is it's more than just the execution layer. It's a little bit more of the consensus layer, like Akaki was mentioning, and there's a lot.
Are there any other questions at this point? Okay, cool, we can continue. So are there any ongoing efforts in the Ethereum community aiming to standardize some of the EVM stuff on the layer 2? Like I know, for example, that Arbitrum pre-Nitro had its own implementation of the EVM, and now after the Nitro hard fork, you kind of became much closer with the version of Geth. The same thing was with the Optimism pre-Bedrock. So like, are there any ongoing efforts there to standardize across all L2s, or even should we do it?
So I'm not aware of any. I would love to be involved in those if they exist. I don't know, I'd like to see more.
I can add a little on this question. So yeah, there is definitely not enough efforts in this direction, and it's very hard to even find all of these differences and changes because they are documented like separately for each rollup. So if you want to learn about like differences on Arbitrum, you go to the Arbitrum documentation. If you want to learn about optimism, you go to optimism documentation. So there is no like single place where you can find all of this information aggregated in the same format. So one of the interesting direction in this improving this kind of problem was the introduction of the rollup improvement proposals kind of format. So previously we only have like EIPs and ERCs, which is part of this standard for describing Ethereum improvement proposals during these hard forks. And then someone proposed, let's use them as well for describing different rollup improvement proposals. And if you have like certain opt-in and opt-out features in the rollups, let's put them kind of in a single directory and manage them all together. And maybe, in the end of the game, we can like have this single place which describes all the differences that different rollups may have or may not. So that's probably the good direction to look at.
Aki, you want to add?
Yeah, so I'm also not aware of any efforts, but what I think is L2Bit can do that because they are doing very good job with estimating how well the rollup does. So they can also maybe measure how compatible they are, and that will push rollups to standardize more and more. But again, as you said, Arbitrum really tries hard to be updating as soon as Ethereum does, basically same day or same hour. So we are really trying to be as close as possible. But that would be a nice tool to see on L2Bit. And I also want to shout out to them because they introduced now this L1 finality. There was this previous question which measures time, how quickly rollups go to base layer, and that should be also helpful for users who rely on decentralized exchanges and their monitoring.
Awesome. And with the Dencun hard fork happening some month ago, like what do you expect is going to happen in the near future? Like what are some of the things that you expect layer 2 solutions will implement? And we can start with you, Akaki, since you're with the Arbitrum.
I'm really excited about this upgrade. And so far we've seen very low blob prices. And what I'm expecting is more users. So what we are observing so far is more activity, but from the same users. But if transaction fees on rollups, especially on optimistic rollups, but also ZK rollups dropped significantly. So if this sustains for some time, then I'm expecting definitely many more users that we are not there in the first place. And then maybe fees will go a bit higher, but never to the same level as it was before. And once we reach the level where we are consuming a lot of blobs, maybe Ethereum Foundation will add blob capacity. And so that this is this dynamics that I'm expecting. So we won't stay with these 3 blobs, but we will have then more blobs, target number, and in the end we go to this, what's the name? Dunk sharding, full dunk sharding mode. So that's the best dynamics that I'm expecting.
Sure, I think you said it well. I think the expectation, I think, will be cheaper and more users for sure, but also this will mean better scalability on Ethereum if they add more blobs, which I think will be absolutely necessary right now to beat 30 or 40 rollups out there right now, plus 20 in development or something. They're going to need to be having a lot more space to post things. But I don't know, I'm just excited. I think you said it all.
Okay, and how do you see all of these varieties in the EVM affecting the tooling and the infrastructure components that are out there helping developers be more productive and efficient?
So I think this was the question that the audience asked, is sort of like, what is this beyond just does my Solidity work? And I think that's going to mean a lot of work for a lot of people as they sort of pick and choose their favorite chains. Ideally, everything works the same, but as we've already discussed, some chains operate at different block times and have different behaviors, and reorg depths can be very different among them. So I think it's going to be a lot of work. I mean, I hope we can at least standardize sort of the API calls you need to make, if not the behavior, because just changing one of those is going to be enough to keep people very busy for a long time. But I think I think we'll really see maybe an advantageous sort of set of tools come out for chains that do things very differently. Like if they can perform different analyses, or can support different ways of integrating on that chain because that chain behaves slightly differently. I think that would be really cool. I don't know what those look like. I don't have any ideas for what that would look like, but if you start changing the behavior of these rollups anyways, which I think you'll see people doing, like let's do it for the better. And so let's build some better tools. Like what tools don't we have that we do want? Is Dune Analytics sort of enough? For example, like would there be a better analytics engine, not that Dune is bad, if there were different systems to work with, or different support by the rollup itself? And I think seeing those changes will be really cool, but I don't know what those look like, or if they're possible. Maybe that's it.
Yeah, another good thing I think makes sense to add is that at least although we have these hundreds and thousands rollups already, at least we don't have like hundreds and thousands implementations for this rollup. So it's nice that basically everyone is using one of these rollup families or stacks. So we have only a few of them. So it makes it easier to support everything. So at least kind of narrows the efforts required to support as many chains as you want. So I think for now we have only like 4 or 5 majorly used stacks, like Optimism stack, Arbitrum Nitro, and Orbit stack, ZK Sync and Polygon CDK. Yeah, I think something like that. So at least people are trying to converge to to a single rollup family. There are not too many of them, so that kind of simplifies the life of tooling and infrastructure.
Yeah, I agree with that. And what do you think are some of the security implications of having this many varieties of the EVM implementations on layer 2? Like, are we going to need to have security auditors specialized just for some implementation of the EVM, and are they going to have to look out for like each new hard fork, and what do all of these chains introduce on the EVM level?
Yeah, I think one of the things I noticed recently within like the past year in the security space is that now it became basically a requirement, mandatory requirement for whenever you are ordering an audit from a security firm or starting a security contest, something like that. One of the first question is basically which chains your protocol is supposed to be operating on, and you like select if your protocol is supposed to be only working on the Ethereum mainnet, or if it's only supposed to be working on Arbitrum, and then the security researchers use this information to kind of assess your protocol according to the nuances and the security implication for each of those chains. So that's important thing to consider. And then it's also an important point that the original protocol developers, they ordered an audit for some protocol on Ethereum mainnet, but then some guy came in and forked this protocol and launched it on some rollup without changes. So yeah, that kind of shorts the security as well, because this protocol was not originally audited for that type of rollups, and so that kind of might be a problem at some point. So yeah, people just need to pay attention when they review in the audits if the protocol was audited for the certain chain they're planning to use it. Yeah, I think that's it from my side.
Yeah, so I actually think I agree with what Jan said before, that protocols should do, of course, their due diligence and deploy on the testnet, and then they need to talk to rollup team and find out the remaining details they may have missed. I don't think there will be a security service that will check all the subsets of rollups where your protocol will be safe. That will be too much to ask to anyone. But yeah, so protocols themselves should go through this process, I think.
Yeah, so I agree with both of them. I think that first one is really important. If you get an audit, tell them what you're deploying on, because sometimes you might not even think, but if you have any inclination that like, oh, you're developing a dApp and like, maybe I'll put it on Polygon later, tell them up front so that the persons can figure out what that implication are, if there are any. But I also think there'll be new avenues for places like security people in this space. So at Zirkit, one of the things we're doing is sort of sequencer level security, where we'll prevent bad transactions from executing on the L2, whatever that means, and I had to talk on that. But how that could be done could involve other security auditors, or could involve different people taking an active part in the security of the system that isn't just in the state transition function. And I don't know what all those things look like, but you could envision involving them in restaking protocols to somehow do something on the governance of the chain, or maybe you have a prover market that requires some level of security that can't easily be implemented just on chain using economics or something, or technically. And so I think for now the answer is pretty straightforward, like the other two said: test and talk to auditors and do these things. But I think in the future, you're going to see a lot of very different things. And you'll obviously see very specialized security risks on very specialized chains. Like, what is the implication of a new opcode going to do, and things like this. And it will be very interesting to be researching in that space, because you'll see hacks probably happen on a couple of chains, and then probably they won't be as successful on other chains, and not just because the flash loan value wasn't there and liquidity was fragmented, but because some chain actually prevented it in some way, whether that was intentional or whether that was just they changed the block time parameter and it saved them, will be very, very interesting. And I think that has been really underexplored. Like, I think there would be really lots of good questions to say what is possible only on some chains, or only if some chains change some property that others which don't have that, wouldn't be affected by. So I think it's going to be a very interesting space to be a security person.
Thank you so much. Are there any questions from the audience? Yeah, we have one there.
Thank you. What are the current biggest challenges in the L2 EVMs? Are there any global challenges that needs to be solved?
There are definitely challenges. I think the prover times for ZK provers have come down quite a bit. You can probably still do better. A lot of research going into that. I would say that's where I'm focusing a lot of my time, because we're in testnet. So I'm sure there's others, though. I'm sure there's things like decentralization. We all probably want to be there at some point. And what does it mean to decentralize a sequencer? Is it the same as decentralizing a network? Do we actually add consensus overheads if we do that? And so should we do that? Are there other challenges related to getting other people involved in other parts of the system? For a zero-knowledge system, that would be like decentralizing the prover, right? Is it easy? Is it hard? I don't think there are a lot of chains out there that have a complete picture of what that looks like. I could be wrong. I think some others are definitely attempting it. But I bet the solutions that we have today won't look like the ones that we have in 2 years or 3 years, right? So I think there are definitely challenges. It's a little hard to nail the specifics.
Yeah, so my top pick was actually what you mentioned, this ZK rollups proving EVM state, but there is significant progress, as I understand. Another is maybe shared sequencing and interoperability, and their EVM real compatibility would be really useful if all rollups had that. Then we could have this glorious shared sequencer.
Yeah, there is also some research going on into adding a multi-prover setup for the rollups, so that you can prove the rollup state independently using different engines. So you can have multiple ZK provers developed by different people and using different strategies to prove the same EVM. And then if all of them agree on the same state, then you can be more sure that this state is indeed correct and wasn't manipulated in any way. You can also combine the ZK and optimistic approach together to also increase security. There is some interesting research going on for the future years for the parallelization of EVM. So if you can parallelize execution of different transactions that don't touch the same set of accounts or whatever, if you can execute them in the same parallel environment. So that's one of the interesting approaches as well.
Yeah, I got one more, which is probably just interoperability of these systems, right? You're going to want to have people move liquidity from Arbitrum to somewhere else, or vice versa. And I know there's been a ton of bridges, but bridges have been so problematic in the past. There's probably going to be new innovations in this space. And I think it'd be interesting if you could somehow work that in, either through shared sequencing or some other way that's unique to sort of a layer 2 environment.
Yeah, actually I have one more too. This is a question I'm very interested in personally. It's multidimensional pricing of resources. Because what we see now is biggest problem in EVM is state growth, and everything follows state growth, so that's the biggest bottleneck. Of course, there is parallel execution, but I think before we go there, so if we solve parallel execution, that won't save us because there is state growth, and that needs to be accounted. But what is happening now, we have just one gas unit where all the resources, opcodes, are translated into and priced in the same way. While it can be that some transactions don't grow the state at all, and they should be priced less. So this is now done manually, so the conversion between different resources into gas. But it would be nice to have parallel independent, maybe not independent, but parallel markets for each resource. Of course, we cannot have thousands of different opcodes priced differently, but what we see with this EIP 4844, this is first attempt to go to multidimensional pricing. So now we are pricing cold data separately. So this is, I think, a symptom of a bigger problem. So we knew that rollups are overpaying for cold data because if we can afford now these cheap blobs, we could have done it before too. But because everything was connected with state growth and single dimensional pricing, there was this problem of rollups paying too high number. And I think this is the same happening now with other resources on Ethereum. And if all rollups are EVM compatible, they are inheriting the same problem. So this multidimensional pricing, I think, needs to be done and will be done in some way. And I think this is where rollups again can, together with Ethereum, collaborate and, for example, agree on the new transaction format which specifies their willingness to pay for different resources, for example.
Thank you. Any other questions from the audience? If no, like, guys, if you have any final words to say before we adjourn. No?
I'd like to say thank you. Thank you. This was fun.
Awesome. Thank you so much. Thank you guys for coming.